In the sunlit sands of ancient Egypt, craftsmen first tamed the power of rotation. With simple bow drills and copper bits, they pierced stone and shell, not for oil, but for ornament. Yet here, beneath the desert sun, the first sparks of mechanical drilling were born. In the great halls of Alexandria, Greek minds turned to mechanics. With gears and shafts, they explored torque and motion. Though drilling remained crude, their ideas planted seeds that would turn for centuries to come. The Romans drilled for water, not oil. At aqueduct sites, hand-powered augers bit into rock. Their tools were strong, their ambitions greater, but the earth held its deeper treasures just out. Through centuries of shadow, Europe's drilling knowledge stood still. In dim blacksmith shops, iron and wood met stone by hand. Progress was slow, invention idle, but not. Leonardo da Vinci saw machines in motion. Sketches of cranks, cams, and spirals filled his notebooks. He never built a drill motor, but his vision sparked a mechanical renaissance that reawakened possibility. Old dark mines, steam hissed and gears turned. The Industrial Revolution gave drilling its first real machine muscle. Iron augers bit deeper, faster. The idea of powered drilling had arrived. Across the Atlantic, inventors took notice. A rotary drill, patented in America, spun hope into iron. It was noisy, inefficient, but it marked the turning point toward a future underground. Then came Spindletop. Black gold erupted skyward, and the oil age began. Yet deep rock pushed back. Rotary drills alone weren't enough. A new idea was needed. Something smarter. From beneath. Challenge of Deep Rock, West Texas, 1905. Drillers battled hard formations with broken bits and boiling tempers. The surface could spin, but deep underground, torque was lost. Engineers knew the answer had to come from downhole. In a quiet California workshop, a young engineer sketched the impossible. A motor that worked underground, using mud for power. It was a spark of genius in oil-stained sleeves. In Pasadena, prototypes took form. Turbines encased in steel, designed to spin a bit without surface drive. The mud motor was born, heavy, raw, and full of promise. The first field test failed. Bits jammed, motors overheated, tools cracked. The dream teetered, but in failure, data spoke. The design needed refinement, not abandonment. Across the world, Soviet engineers took up the challenge. In freezing fields, they improved the turbo drill, stage by stage. It was here, under ice and pressure, that the motor showed its strength. In Siberia, a quiet revolution. The drill turned below, while the surface stood still. No rotary table, no wasted torque. The motor had proven itself. In silence. In Houston, the positive displacement motor was born. With rubber stators and spiral rotors, it changed the game. More power, more control. Reliability had arrived underground. Offshore, the motor met its true test. Deep under the Gulf of Mexico, it worked flawlessly. Engineers knew this wasn't just invention, it was the future of drilling. Motors soon guided bits through solid rock, curving wells with surgical precision. Directional drilling reshaped the industry. Wells bent toward reserves that once lay unreachable. Today, autonomous rigs and AI-assisted motors explore the earth with unprecedented precision. What began with a bow drill and a sketch now powers the energy that moves the world. Today, autonomous rigs and AI-assisted motors explore the earth with unprecedented precision. What began with a bow drill and a sketch now powers the energy that moves the world.